Hello, everyone. I open the chat. Okay, how about sound? Do you hear me? Okay, so let's get started. Today we continue talking about next step after EDA. EDA, the exploratory data analysis that we have performed last week. So in the exploratory data analysis, the main idea was to uh, get the view of our data to understand what are the columns inside our data, how are they related, to visualize something, to find the histograms, distributions of our data, and get the whole spectrum of what that cow Lee. Okay, and the exploratory data analysis was a pretty useful step for us just to understand whether our data is possible to model then or not. So are there any missing values? Are there any outliers? Something like some very large or very small values inside our data. So this exploratory data analysis is the preliminary step. Now, after we have discovered some insights from our data, it's a very good time, very good sense to try to model something, to build models. And this R programming course will be devoted only for 1 week for modeling, because it's very similar field, but not very not very how to say it, not very useful to get in deep inside this course. So for the modeling part, for exploring the power of R, there is next semester's course, which is called econometrics. And in this course, we will build lots of models, and you will find out that R is quite powerful for building models and exploring data in the model sense. So why econometrics is important? So we have the law, like economic law, or some kind of the dependency, and we just need to measure this dependency based on the data we have. So we have to provide quantitative view to quantify this dependency, to understand on how much exactly there is the dependency of one variable to another, or one variable to the bunch of other variables. And so we'll explore some straightforward stuff, the classical linear regression models, and when the assumptions of linear models are violated, and how to deal with them, and then to how to use econometrics for forecasting, for usage in time series analysis, all this stuff, which is very important for finance. So in this R programming course, our whole idea is just to demonstrate a couple of things according to the model building of what we are coming from the EDA to model building, and what it means to build a model here in R. So this week 14 lecture is available on Moodle, so you have to open this file, try to load the libraries, the ggplot2, and inside ggplot2 there is diamonds dataset, as we have explored the last week, and in dplyr or in tidyverse there is the New York Flights 13 dataset. So we'll work today with both of them. This is the we just go through the notebook. The whole code is already written, so it will be quite fast for us to just get used to it. We have to build, have to continue have to continue like exploratory data analysis to just before we model, we demonstrate what insights we got from the data. And using ggplot, let me also try to make it. Maybe I'll make it this way in order for you to be okay with that. That will be lower. All right, so we have we are building those box plots just to get the idea of what are the interquartile range IQR from 0.25 to 0.75, and the majority of data lies over here. Here's the minimum, here's the maximum point, and after the maximum point there are outliers which are farther than 3 standard deviation from the mean, and this is black line is the median. And according to the boxes, we can see that the fair priced diamonds cost larger than ideal cut diamonds, which is non-reasonable at all, but we have to transform our data so to get the real understanding of what our diamond price are. So this is the ggplot which is formed with the cut and price. We also can change this and try to get the understanding what is the cut and what is the price and color, how they depend, and we see that yeah, okay. These are the colors of the diamonds, and again we see some not very great relationship, which is opposite to the common understanding of the quality of diamond and the price of diamond. So these are the colors of the diamond, and the D and D are the best qualities in color. They are colorless, no color at all, very, very, very slight color, and this is the color diamond, which may be like yellow, which might be some kind of different color, and usually the colorless diamond should be priced larger than colored diamonds. So this again is not the relation we are looking for, and we try to get rid of some data to model it so that the colorless diamond will be priced larger. And the third characteristic is clarity. The clarity, we can see that the again infinitely quality without any inclusions, they are priced lower than with inclusions which are can be seen with naked eye, and also this is not very, very great. So we have some, if let's pretend, for example, that we're given the data and we're asked, all right, just perform the analysis on based on the characteristics of cut, color, and clarity, and find out whether the price depends on these characteristics and by how much. And you will build these 3 types of graphs, these 3 box plots, and you will just get their own impression of the real thing. So modeling is very important. It is crucial, and we have to perform modeling. Next, what we are going to use, this is the Geom Hex. There is the package I call install package, and I type the install package hex bin like that. Here we specify something like hex bin in order for it to work. Hopefully in Windows everything will be automated, so you will get some kind of hint to install the package. So here is the hex bins, and we specified how many points to place inside the single bin. What do we see here? We see that there is the relationship which goes non-linearly. It goes something like exponential relationship between the size of the diamond and its price. So we have like the exponential relationship. And here are the countings, and we can see that the color, which is really light, here gives us the impression that the majority points are situated here in this kind of in these pins. The other points are just the contain not much observations, and we can see that the darkest side contains less than 1000 observations, but it might be just like 20, 30, and we place the point which contains several observations, or maybe this is just a single point. So what are we going to do? We will start with creating the variable which is called diamond2, and diamond2 is made from the diamonds, which is the data set which contains 64,000 observations, and we filter this data set based on the amount of carats. As we can see that there is a point with the 5 carats. Okay, here it is, and so we just limit the data set cutting on this value 2.5. That means we will leave the majority of data inside the data set, which we'll call diamond2. And to get rid of the exponential relationship, we will use the log2 transformation. So every data point will be transformed with not the exponent, but 2 to the power of something, and because of the log2. And it will allow us to linearize this relationship, to make it not exponential, but to make it straight line. All right, so this is it. We have deformed, and we can see that 53,814 observations are left after our choice. Of course, we can change this amount slightly. Maybe we just include 3, but there are not that many points. So let's deform and just see that we added only like 400 points, and this is neglectable according to our observations, or not 400, 100 points. So we might also divide this relationship to 2 parts. Let's say that 2.5 is the cutout of the whole relationship, and then we also may divide the diamonds which are less than 1 carat in size and more than 1 carat in size. But we have to think because there are lots and lots of diamonds which are 1 carat in size and which are sold. The majority of diamonds is like the 1.25, 1.5. So people like those beautiful numbers. So we have to understand maybe 1.01, 1.02. They have to placed in the one category and the others to another category. All right. Next, after we continued and we are here with this amount of observations, we just plot those numbers, and we got what we needed. So we obtained this kind of linear relationship. We can see that now the prices the prices represent the 2 to the power of something, and number of carats, this is the actual logarithm of previous carats. So 2 to the power of -1 and 2 to the power of -2. So our all relationship is so 1 means regular 2, right, and slightly more than 1, which it is the carat which was initially 2.5. So logarithming is a really great technique to make our relationship straight. Why we are doing this? Because the majority of models, they like that the data is linear. That means we might use very very old, I would say, very old techniques of regression to understand the relationship, to build the line which goes through the points, and there is some kind of the quality of this line which measured from the points to the line, these distances. Here is the line, here are the points, and we measure the distances, we square them, we take the square root of them, and we got the metric which is called RMSE. The sum of all distances between the point and the line squared and taking the square root of that. RMSE, which is called root mean squared error. This metric is used throughout the econometrics course, and the majority of models are based on these metrics. So far we built this plot, and here is this plot which we can see the linear relationship, and now we are able to start modeling. So modeling in R is really simple. We have the command which is called LM. LM is the shortcut from linear model, and the whole commands are placed in this kind of setting. So at the left-hand side, after LM and we open the brackets, at the left-hand side is the Y variable, the variable which depends on the other variables. So we want to find out what will be the L price, and the L price is our log 2 of price. So what will be this variable depending on this variable, which is x in our graph? What will be the price depending on the caret? And we just pass the data, which is 53,000 observations from our data. And here is the sign which is called tilde. This tilde is the button on your keyboard upper than tab. So you press shift and this button, which to the left hand side of one key and below the escape key. This single will be the apostrophe, and here is tilde when we try to use shift with that. So this tilde separates two objects, the y variable and the x variable inside that. And everything will be placed here in our model diamond variable. So we can see that the model diamond is the linear model, and inside model diamond there are several things which are written. The one of the columns inside this model represents the coefficients. So we will able to get our coefficients at hand, and we may explore them. As you might think, what are the coefficients? And if we are building the line, and here we build the line, y equals first coefficient plus second coefficient times L caret. So we'll have two coefficients here, and you can see that here they are, the intercept, which is 12.19, and the coefficient before the variable, in front of the variable L caret. So we start somewhere in 12 point something, and we modify the line based on our caret. And of course, we have to get back to our data. So later on, we will need to change our logarithm values to regular values with producing them to power. Okay, here are the coefficients. Here are the residuals. And if you can see that if coefficients were only two, here they are 12.19 and 1.68, the residuals are equal to the amount of data points. So data points were 53, 8, 14, and we have the same kind of residuals. Residuals are quite important for us because we will be able to use them as the variable. Uh, and later on, I'll show you today. Later on, I'll show you how we are using them. So let's continue our observations. By the way, do you have any questions? So if no questions, let's continue. Next, what we need to do, we need to create a variable which we will call grid, and this variable is based on our dataset diamonds2. And what we are going to set. There is the commands which is called sequence range, and sequence range just creates the vector starting from this value adding to this value with the with even spaces between them. So we may just copy. We may just copy that inside our cell. Press Ctrl Enter, and caret will be the caret which is given from given from the diamond. So if we place like 1, we will have the range of 20 observations with this kind of with this kind of value. So at the first, this is our first step of data transformations, and then we will create the L caret variable inside, which will be our log2 caret, and we add the predictions of our model. Here is our model. Our model and the values for L price. So our L price will be based on, let's say we have the single caret, and with this single caret diamond, we will have the price of the diamond 1219 plus 168. Of course, this is really rough because we need to use at least those values. Here they are. Plus and times the amount of caret, and this is one, just one. And here's the price in our log. Our log2 price will be like that. Okay, so 2 to the power of this will give us the regular value. Okay, like that. So we have $15,000 for 1 caret diamond in like the average value. And is it good or is it bad? We don't know yet because we haven't explored our model, but still for like our preliminary topic, it's okay just to model the price based on the caret only. And if we have the 2 caret diamond, so the price will be like that. Reasonable it is or not, we don't know again, because let's say we have diamonds 2. Do we have the price? We have the price, and maybe it's reasonable for us to calculate the maximum, and we can see that the maximum price actually is 18,000. So our model, which we try to model the price based on carets, is not very good. But still, we have to add some variables to make this model more complicated, and it will shift our prospection of our. Hold on, maybe we need to the power of. Yeah. Okay. So maybe we will need to change our prospection of the prices based on that. Okay. So here here is our grid. Let's create only this function over here, grid. I select that and press Ctrl Enter. So only this command is implemented, and let's have a look what we have our grid. Our grid contains 20 observations because we just used the creation of the sequence range of 20 points. So inside these 20 points, we see the logarithm value of caret and logarithm value of price. And the price, which is 2 to the power of these values. And we can see that the 2.5 without modeling, just to change the log price to price and change the uh, log caret to caret based on our transformation 2 to the power of something, we end up with these values. So based on our grid, we are going to plot, going to add those data points, data from the grid, and we place these red points just at the same points which we find over here. So we will place the first point based on this minus 2.32 and 8.28 based on our grid. And let's have a look. So we see the points, and the preliminary point is over here. There are also some kind of several points over there, and the line which is the command from ggplot, it just unites this point and places the line between them. As far 20 points is enough for us to get really a smooth line, and we can see that this kind of line is just the log2 relationship between the caret and price, as our model says. And let's make our plot a little bit larger. You can always press the zoom button and you'll get the separate window, but because we are recording, I have to use these kind of shifts to get our perspection in larger value. Okay, so we have this line which passes through the majority of our data. We can see that the majority of our data is over here. So our 20 points, they are passing through this data, and that means our model is doing okay. So maybe our calculations here were not that correct. Maybe we have to change these values just to calculate what we have. Maybe we need to change this value of 1. Let me have a look. The value of 1 means that we have got the two-sized caret diamond. Okay, and the value of 2 means some data point which lies far beyond the which lies far beyond the available data. So we cannot use just plain 1 and 2. We also need to transform that. So our model doesn't work that way. We need to just calculate the predictions based on our model to get the price, and then use 2 to the power of this log price at hand. But caret should be the log2 of caret. So our log2 of 1 will give us 0, and log2 of 2 will give us 1. So if we get back and see, this model is for 2 caret sized diamond, and the relationship that we got, and this is for 1 caret size. Okay, so our 1 caret size diamond will be this price, and 2 to the power of, hopefully we got, and this is for 2 caret size diamond. And now our prices are really reasonable, and they are according to the data. So we need to be care of not interfering the regular variables to modified variables. We also need to modify variables to get the results which are okay. And one caution extra, we also need to always try to calculate by our hands to get the feeling of is everything going okay or not. So all our data, let's get back to our graph, we can see that all our data is cut at these options, at these prices. There are no single diamonds in our data set which costs more than 19,000. All right, now we are going to use our Diamond 2 data set, and we add the residuals from our model. So we are going to see. So we're going to add this variable, these residuals, these values minus 0.28 and so on, to our diamonds data set, and we will have the next variable there. And we can see that here is the extra variable which was created from model diamond using the command add residuals. Okay, and after we added that, we used the lcaret and lrez, so this variable and this variable, to build this kind of graph. So we can see that those points which are on the zero value over here, they are predicted okay. And we can see that the changes, the residuals, the value of residuals is really big between 0, that means 1 carat diamond, the largest one. So it's harder to predict the price of the 1 carat diamond over here. And it's rather easier to predict, but the price range, of course, is not that great for lower cut diamonds. So using the residuals, it's more reasonable for us to use residuals to plot the these kind of preliminary perceptions of our data, not just using the cut and the price, but using those values, the cut and the residuals from our linear model. So let's do them one by one. I will just press Ctrl Enter on each of them, and we can see that the ideal price diamonds, they actually cost more, and the same kind of thing goes for color, that the colorless diamonds cost more than colored, and the same applied to clarity, and the non-inclusions cost more than inclusions. So this is what we have to do in order for present the results from our data. And that's really, really important for us to get the real understanding of the data based on the models. And what model we did is a very simple model. We just they took the assumption about that the logarithm of price depends on the logarithm of the carat. And using these residuals from the model, that means we place the line through our data, and we measure the distance between the line and the point. This is the residual, okay? And for our model, the first residual was just 0.28 to the minus side. And there are, of course, some kind of residuals which are higher than our line. And we add those residuals and got this second variable lrez. Okay. So that's it for our first recording. We need to reconnect. Okay, so please reconnect.